This video will cover the Year 9 Nonlinear Algebra test preview for the fundamentals section. So these are C-style questions. I'll put some links in the description below for you so you can skip to question numbers or question types. Question 1, substitution. So we are giving a value for x here, and we just need to replace all these x's with minus 5. So y equals x, which is now minus 5, minus 3, all squared. Let's collect up what we've got in the brackets. Make life a bit easier for us. Minus 8. Notice I've left it in brackets there. If you're using a calculator to solve this, you need to use brackets or your calculator will give you the wrong answer. So minus 8 times minus 8 gives you positive 64. Second example, we've got a few x's to replace here. So y will be minus 5 squared. Again, again, it's in brackets, plus 3 times minus 5 plus 5. Simplify this a little. So minus 5 squared will give you 25. 3 times minus 5 gives minus 15. And then we're adding 5 back onto the end. So y will be 25 minus 15 gives you 10. And then 10 plus 5 gives you 15 as your final answer. And the last one, y will equal 3 times minus 5 squared plus 2. Just write this one a different way. Times minus 5 means the same thing, just to mix it up a little bit so you can see there's a few different ways of working this out. You can put it straight into your calculator like that as well if you like. So that will give you minus 5 squared is 25. 25 times 3 gives me 75. Then I've got 2 times minus 5 gives me minus 10. And then I've got a minus 6 on the end. That's a negative there. We'll solve this one. 75 minus 10 gives me 65, and 65 minus 6 gives me 59 as my final answer. Question 2. Looks like we're substituting again. This time x has got a value of minus 1, and y. Now we have to be a little bit careful with these ones. Let's have a look. They've got a y squared here. So let's sub in and work it out from there. So y squared will be 16 minus negative 1 squared. So we're being careful with that negative there. BODMAS comes in here. We've got to do our orders and our brackets definitely before any adds and subtracts. So here what we've got is, I'm going to show a little bit more working out than what's really needed here, but I've got 16 minus 1, okay? And that 1, this one, comes from this here. Okay, so when I do minus 1 times minus 1, I get a positive 1, but that negative sign never went away. Okay, so it carries down to here. All right, let's keep going. So we've got y squared equals 15. And then in balance method, if you want to get rid of a squared, the best way is to square root both sides. So y will be the square root of 15. We can put that in a calculator and get an answer. In this case, y would be 3.87 if it's rounded to 2 decimal places. But in this form, it's absolute. There's no inaccuracy at all. As soon as we round it, we introduce a small error, but that's still a fine answer. Okay, moving on. We've got y squared again equals 2 times minus 1 minus 1 all squared. So again, we're being careful. They're trying to trip us up with all these negatives. Y squared equals 2 times minus 1 makes minus 2. That negative stays there. And then we've got, so that's this negative here that's carrying down, okay? And then we've got minus 1 squared, so minus 1 times minus 1 gives us positive 1. So what I've got now is y squared equals minus 2 minus 1 gives me minus 3. Balance method, let's square root both sides to get rid of that squared. That would make y equal the square root of negative 3. And here's a problem here, because you cannot have a negative number square rooted, because no number multiplied by itself will give a negative answer. So the correct answer to this one is no solution. Alrighty, moving on. We've got another y squared one. So y squared equals 36 plus minus 1. So minus 1 minus 1 squared. Still trying to trick us with these negatives. Let's take this nice and slowly. We've got the 36 minus 1, so that gives me 35, minus, and then I've got minus 1 squared, so that minus there is this one that's travelling down, okay? You don't obviously need to show that. And then minus 1 squared makes 1, so I've got 35 minus 1, so y squared equals 34. And now I'm back to square rooting. So let's get rid of that squared by square rooting both sides. Balance method. Y will be the square root of 34, which if we put it in our calculator, y will be rounded to 5.83 if we round to 2 decimal places. So there are our final answers. Question 3, balance method. Balance method with squared numbers in it. So it's going to be a little bit similar to what we've just done in question 2. Get rid of the 9 before you get rid of the squared here. So in our first move, we're going to divide by 9 on both sides. And we will find that we've got m squared equals 3 left over. And then we'll square root on both sides to get rid of that squared. And m will be root 3, but we need to be careful here. And I was looking at that in the question before this one as well. If m squared equals the square root of 3, it could be positive or it could be negative. Okay, that answer. And I'll try and elaborate on that, because if we chose a number that we know, so let's say that we're doing 2 squared, for example, that's 2 times 2, which gives us 4. But if we made that a negative number, minus 2 times minus 2 also gives us positive 4 as an answer. So when you're looking for m squared or x squared rather than a single m, then it could have 2 possible answers. It could be a positive or a negative answer. So give 2 answers, okay? So this is the correct answer. We don't really need to hit equals on the square root of 3. Let's leave it like that so that it's absolute. All right, this one looks a bit trickier. We're going to divide by 9 both sides. That's going to leave me c squared, and on this side I'm going to have a 9th, which means that we can square root both sides. And so what I'll end up with is c squared, c now, so I've gotten rid of the squared, equals the square root of 1 over 9. And remember, it can be positive or negative. And what you can do with this one is we can simplify this. So if you got to this point, that's great, but we can go a little further. That square root sign here, this one applies to both the 1 and the 9. Square root of 1 is 1, and the square root of 9 is 3. So the most correct answer for this is that c is plus or minus 1/3. And the last one. Let's get rid of the 5 first. Minus 5. It says add 5. I'm going to minus 5 from both sides. That leaves me with 2c squareds. And on this side, I'll be left with 8. Next, I'm going to get rid of that 2. It says to times, so I'm going to divide both sides by 2. I'll have c squared left, and over here I'll have 4. This one should work out nicely. It says to square, so I'm going to square root. All I'll have left is c, and on this side I'll have positive or negative 2. So this is a great example of what I was talking about earlier. Remember that positive 2 squared would make 4, and negative 2 squared would also make 4. That's why there's 2 answers. Okay, null factor. Null factor is great. It's nice and fast. So I'll show you how to do this very fast, and then I'll explain why it works. Whenever you see these, all you do is you just take these numbers, and x will be those, but the opposite symbol. So x will be 9 and 3. I don't usually bother writing and, I just put a comma in between them. You can do that if you like. So there are two answers to this one. When we start graphing these, you'll see why. But the reason for this is, if I made x 9, then what I'd have is I'd have 9 minus 9 times 9 minus 3. And that would be correct because this part of it would equal 0. And 0 times this would happen to be 6, but whatever, it'll end up having a 0 answer. And similarly, if I made x3, I'd have 3 minus 9, which is minus 6, but that doesn't really matter because 3 minus 3 makes nothing, and anything times nothing makes nothing. So that's how we get to those answers. So when we have a look at the next one, straight away you can jump to, x is minus 7, and in this case there's only one answer, but it has to be minus 7 if you think about it, because 7 minus 7 squared is nothing, and that equals nothing, so that satisfies the equation. You don't have to show these proofs with null factor method. We know that you know what you're doing. Let's have a look at the last one. Whenever there's something outside of the brackets, like this 4m out here, then that means that x is nothing, and it's also, positive 7 because of this one here. So let's just work that again, just so that it's nice and clear. Remember, we're trying to make it equal 0, hence null, nothing, and then factor, as in this is a factor and this is a factor, and we're trying to make one of them 0 at all times. So if x is 0, that's great because we'd have 4 times nothing out the front, and then it really doesn't matter what's inside, does it? Because you get the answer 0 anyway. And then if we make x 7, we'd have 4 times 7 outside, 28. That doesn't matter, does it? Because if we put 7 minus 7 inside, it's going to be 28 times nothing, which would give us 0. So these are your final answers here. Question 5 is asking us to plot this quadratic here. And so we haven't done much of this yet. So there's a few clues that we can get from these. They're a bit like linear. This tells me that it's going to have a positive trend, and this tells me where it's going to intercept the y-axis, just like in linear. So I'm being careful here because there's a few instructions here. I have to complete the table and graph it, and I also have to mark each axis, include a scale, and put in some key points. So let's start by marking this. I've got a x and a y axis. I'll make this positive 10, this positive 10, this negative 10, and this one negative 10. Now I know it's going to go through 5, and because it's a quadratic, it's going to look something like this, but I need to use the table on the left to find some key points. And the way to do that is substitution. So this table is saying when x is 0, 1, 2, or minus 1 and minus 2, what's y going to be? If you've got a calculator, the easiest thing to do is to set your calculator up with some brackets wherever there's an x, and that way you can just keep changing the value. So if x is 0, 0 squared is nothing, and nothing minus 5 is minus 5. And then you can skip back and change that, or we can just do this in your head. If x is 1, then 1 squared is 1, and 1 minus 5 is minus 4. You just keep writing them in as you go. And then if x is 2, 2 squared is 4, and 4 minus 5 makes minus 1. You might notice that I started at 0. I like to do that, especially with these, because they are just reflections. So we'll see in a minute that this will be minus 4 and that this will be minus 1 as well, which means I can do half the amount of work. But so I'm not lazy. Let's put in minus 1. Minus 1 squared is 1, and 1 minus 5 is minus 4. And then if we make this a minus 2 squared is 4, and 4 minus 5 is minus 1. And now all I need to do is come over onto my Cartesian plane and plot this. So I've got 0, minus 5, like we already knew when it crossed the axes, the y-axis. I've got 1 and minus 4, and I've got 2 and minus 1. Remember to go across before up and down, x before y. And then the other side is just a reflection. So if this hasn't become clear, just remember that these here, these form coordinates. So I've got the coordinate minus 2, minus 1. I've got the coordinate minus 1, minus 4. Oops, that was a bit of a funny comma. This one's the point 0, minus 5, etc., etc. And you don't have to write those in, okay, like I've just done there. They're just so you guys know that I'm reading those as coordinates to plot. And then when we go to sketch this graph, what we do is we freehand it. Don't get your ruler. It has to be a curve, okay? So we don't want to see a dit with the ruler so that it's nice and neat. We want you to just freehand it as best you can. Put an arrow on each end because this curve goes forever. It says that I need to mark some points here too. So let's mark some significant points. We've got 0, minus 5. I'll just make this a little bit bigger. We've got this one here. This one's going to be 2, minus 1. This one can be 1, minus 4. We've got this one over here. So we've got minus 1, minus 4. And last one, we've got minus 2, minus 1. And we've got that question completed. All right, and moving on to the last one, bit of an unusual question. In this one, we've got a y squared equals. So let's have a look. We can first of all set our calculator up like we did in the question before so that we can sub in values. So we're going to go with y squared equals 16 minus, put brackets in like this so you can just sub your values in. And at this stage, I am solving this line here. So let's put in 0. I like to start with 0. So if x is 0, then it'll be 16 minus nothing. So this one will be 16. If x is 1, 16 minus 1 is 15. And if x is 2, then 16 minus 4 is 12. We know that the other side is going to be a reflection, like this. Now, we need to square root all of those numbers in order to get y. So if we square root all of these numbers, then we'll get these ones here, okay? So what we're doing is we're solving each of those in order to get this. So we're going to need a calculator for this one for sure. The square root of 16 is easy. That's 4. But remember, it can be plus or minus 4. And the square root of 15 is plus or minus 3.9. The square root of 12 is plus or minus 3.5. And the other side is just a reflection. So this is plus or minus 3.9. This one is plus or minus 3.5. Now, when I go to plot this, I'm going to have to do the same thing again. I'm going to have to include a scale and mark in key points. So this is our x-axis, this is our y. Let's go for 10 again. 10, minus 10, and minus 10. And I'm noticing on this that what I've got is I've got 2 y-intercepts. So I'm going to try and make this nice and clear. This here, where x is nothing, I can see that this is going to intercept at both positive 4 and at negative 4. Now, this is going to obviously be a very unusual line. In fact, it's actually going to turn out to be a circle. The problem is I don't know where it's going to intercept the x-axis. Now, if it's a circle, I'm going to guess that it happens at 4, because if it's going through here at 4 and it's going through here at 4, it stands to reason that it's going to go through here at 4. So what I'm going to do is I'm going to test that theory. I'm going to add another box to our table over here, and I'm going to test what happens when x is 4. Okay, so if I put that into our equation in my calculator, 4 squared 16, so 16 minus 16 is nothing. Fantastic. Okay, and the square root of nothing is nothing, so that's great. I know that here when x is 4, y is nothing, and this is also obviously when x is minus 4. If I did one off the other end as well, then it's going to go through here. Okay, so just to make that nice and clear, if I also tested minus 4, there's not enough room to stick it on the other end of the table, then what I would end up with is 0 and 0, okay? Because we'd put a minus 4 in here, minus 4 squared 16. 16 minus 16 is this 0 here, and the square root of that 0 is 0. So now we've got our 4 points, and we've just got to try and draw the neatest circle that we can. And we've almost finished this. Let's put some significant points in. Let's put in that it goes through at 4, 4, minus 4, and minus 4. You could make these coordinates if you want, so you can put them in like this. But because they're on the axis, you can actually get away with just putting those values on. But just in the interest of being thorough, we'll do that. And this is all finished.